Okay, we have seen a similar problem before. Now, I want you to observe that as we have to test continuity and differentiability at 0, let us first see for fun what is f dash of 0. By definition, it is limit x tends to 0 f of x minus f of 0 by x minus 0. I want you to observe that he gave for every x f of x is less than or equal to x square mod f of x. So I have mod f of 0 less than or equal to 0 square. So from this I get f of 0 is equal to 0. So using this information in this, I observe that this is nothing but limit x tends to 0 f of x by x. So to verify whether the derivative is possible or not, I have to evaluate and see whether this limit exists or not. Now I want you to observe that from mod f of x is less than or equal to x square, I can write mod f of x less than or equal to mod x square, or I have mod f of x by mod x is less than or equal to mod x. And we know that this is obviously, this part is greater than or equal to 0. So I have 0 less than or equal to mod of f of x by x is less than or equal to mod x I get. Okay, now if I apply sandwich principle, taking limit as x tends to 0, I'll have this is 0 less than or equal to limit x tends to 0 mod of f of x by x is less than or equal to this is 0. Now I know that mod is continuous function, so we know that we can send limit inside, so I'll have mod of limit x tends to 0 f of x by x is equal to 0, and we know that mod of something is 0 means that something must be equal to 0. So I get this is equal to 0. So two things I am getting, that the derivative at 0 is 0, that means it is differentiable at 0, and one more thing is, as it is differentiable, obviously it is continuous. Therefore option B is the answer. Let's go to next problem. In this problem, we have to find the point of intersection of this line with this plane. Okay, we know that for different values of t, it represents different points on this line. On this line, it gives different points on the line for different values of t. And over here, different value, if you keep on giving different values to x and y, you keep on getting different points on the plane. Now as these are intersecting, for some value of t, this should represent this p, and at the same time from some other values of x and y, this r bar should represent the same point p. So to find the point of intersection, I need to know either this value of t or these values of x and y. So let's proceed for that. You see, for some value of t, this r bar, it is going to represent this p. Let that t be t itself. So it is 2a bar plus b bar plus t times b bar minus c bar is nothing but the point p. And at the same time, for some suitable values of x and y, this r bar represents the same point p, and let those values be x and y. So I have this is equal to a bar plus x times b bar plus c bar plus y times a bar plus 2b bar minus c bar. Okay, now as a bar, b bar, c bar are non-coplanar vectors, I can compare the corresponding coefficients, and I have comparing coefficients of a bar on both the sides. 2 is equal to 1 plus y I am getting, and comparing coefficients of b bar on both the sides, I get 1 plus t is equal to x plus y and x plus 2y, and comparing the coefficients of c bar on both the sides, I have minus t is equal to x minus y. Now From this I have y is equal to 1. Using y is equal to 1 in this equation, I'll get 1 plus t is equal to x plus 2, or from that I have x minus t is equal to minus 1. And from here I have x plus t is equal to y. Y is 1. X plus t is equal to y. So solving these two, simply add, you can see that 2x is equal to 0. That means x is 0. So using that, in one of these two equations I observe that t I am getting it as 1. Now either you substitute the values of x and y in this one, or substitute the value of t in this one to get your point of intersection. So obviously you can see that the required point of intersection is nothing but 2a bar plus 2b bar minus c bar. Okay, let's go for next problem. Now in this problem, see, we know this story. Orthocenter and centroid and circumcenter, if I take, we know that this divides this in the ratio 2:1. Here he gave circumcenter as 0, 0, and he gave the centroid as midpoint of these two. So writing the midpoint, I'll have it as a plus 1 whole square by 2 comma a minus 1 whole square by 2. I have the coordinates of the centroid. Now you can see that the orthocenter from here to here, if it is 2, and then from here to here it is 3. It is dividing GS in the ratio 2:3 externally. So you simply apply the ratio, you will be getting it as 3 times a plus 1 whole square by 2 by 2 minus 3, comma 3 minus 3 times a minus 1 whole square by 2 you are getting. This is nothing but your orthocenter. Okay. So once you have your orthocenter, you can see that it is obviously satisfying this equation, and it is the only equation satisfied by it. Therefore answer is option D. Let's go to next problem. Now in this problem, the line perpendicular to this one is nothing but any line perpendicular to that is of the form x plus 5a plus k is equal to 0. Now we first find the value of k such that it forms a triangle of area 5 with the coordinate axis. Now suppose I have line like this. So x-intercept, if I go for putting y is equal to 0, I am getting minus k comma 0. And for y-intercept putting x equal to 0, I am getting it as minus k by 5. So this I am going for area of this triangle. That area he gave it as 5 is equal to half mod, this is mod k, and this is mod k by 5. So I am getting from this k square is equal to 50 I am getting. Okay. Now I am going for distance between these two. Distance between those two is nothing but mod of c1 minus c2 by root of a square plus b square. That's what I am getting. Now I can see that mod k is nothing but root 50. Root 50 means 5 root 2. But the denominator is root 13 into root 2. So the answer is 5 by root 13. Let's go to next problem. Okay. In this problem, we are given this circle, and he said that it's this equation. It's a chord of the circle. I showed it as AB in the diagram. Now we want equation to the circle having AB as diagram. So this is the circle whose equation we have to find. It's this circle equation we have to find now. Okay, we know that this is of the form s plus lambda L equal to 0. It is x square plus y square minus 16 plus lambda times 3x plus y minus 5 is equal to 0. Now you have to find lambda using the fact that this AB is diameter of this circle. That means the center of this circle lies on the line AB, means this line. Okay, using that fact we have to find the value of lambda. Let's write center of this circle minus of coefficient of x by 2 and minus of coefficient of y by 2. Now this center, it has to lie on this. So I have minus 9 lambda by 2 minus lambda by 2 plus 5 is equal to 0. I am getting minus 10 lambda by 2, that is minus 5 lambda plus 5 is equal to 0 I am having. So I have lambda is equal to 1. Substituting the value of lambda here, you get your circle equation. Let's go to next problem. Sorry, here it is 3, this is 3x plus 5 equal to 0. Okay, go to next problem.